All right, so let's get started. I talked about Python, IPython, notebook environment, Google Colab, a little bit at the end of the last class. So we have a lot to cover today. We'll see if we get to cover everything we want to cover. Just remember today, this notebook generally we go over is to give you a general understanding of Python, how things work. If you have experience with programming from before, this a lot of these should be familiar. It's more of a matter of a syntax, right? To get a sense of or be comfortable with the syntax in Python, right? So I don't go over the initial part, the introduction part. Uh, just get some sense, and let's basically start working on this notebook. So that's going to be the general format of the class. Each session, I'll share with you the notebook environment. Most of the class, especially at the beginning, first few weeks or more of the semester, we're going to be on notebook environment, pretty hands-on. So we'll go over how to work with Python on this notebook environment and how to use the tools that we want to use later for analysis in Python, right? So the simplest code we usually start any programming with, right? It's a hello world. In Python, it's pretty much just print hello world, right? Before you start, if it doesn't really stop you from moving forward, but if you haven't done already, you can just click on top right and make sure your notebook is connected to a server. So you have your RAM and disk space dedicated to you. If you don't do it and if you forget doing it, it's not a big deal. Once you run the first cell of code, that's gonna connect to server by itself. All right. So the way we run a cell, right, in a notebook environment, Shift Enter is the shortcut you can press as long as you are in that code cell. We talked about this. We have text cells and code cells. If you double click on a text cell, you'll see on the left is basically what is typed, on the right what is going to be shown when this is executed, right? So if I execute this while I'm in that cell, Shift Enter, what basically turns into what you see. These are text cells, and then we have code cells, and we can add code cells and text cell wherever we want in our notebook. So to run a code, just basically either click on this play button there or Shift Enter while you're in that cell, right? It's going to run the code. Some fundamentals, if you want to get help, documentation for any command in notebook environment, right? Just put question mark at the end of that command, right? In this case, print is the simplest thing. We'll go over different commands that we can use, but in this case, if you want to get help for this command print, right, you just run this cell, and then depending on the setup in your notebook, in mine is on the right, so I can see the description print. It's going to print a value. There are a couple of options there. We'll talk about print option later on. I don't think today we're going to get a chance to do it, but I'll try to give you more information about print command. There is a lot that you can do with print command, and there are a lot of options and different ways of printing the output in Python. Right. So in my case is there, but in case yours is at the bottom or is in a separate window, it can be changed by this 3 lines at the top right, change page layout. Right. Mine is in the right. You can change it to see the help page at the bottom, or you can click on it and actually have it as a separate window if you don't want it to be in your main notebook window. If I click on a single tab view, then you see in the top right, I have a help page, and then I have my notebook. I can click back to my notebook. So I can close it here. I will put it back where it was on the right of my notebook, and I can just close it. So any command you want to get help in Python, in notebook, this is the easiest way of doing it. Right? Putting comments, it's you can just use pound hashtag, right? And that's gonna help you put comment wherever you want. And sometimes you're running a series of codes or a series of lines. As we said, Python is an interpreted language, so it lines the code, your code line by line. So you can actually kind of exclude that line of code in case you're kind of debugging or something along that line. I put, well, today is not January 19th anymore. So I can update that, 26th, and this week is now it's the 2nd, and that's supposed to be week of the semester. Right? You can run it, you get the output. Now, if I still want to have this cell and I can add something that I had before, just my name, you can put your name. My name is Masood, and it's going to print both of them. Now, if I don't want to see the last print, right, I can just comment it out, as we say, and then just see the first one. So that you can either add comments in your code. I won't go into details of why commenting is important. Hopefully, if you've done programming, you are familiar with the fact that you have to always comment your code. It's just for the sake of others who are reviewing your code and yourself. When you want to come back to that code. All right. So I'll talk about print command later on during the semester. In every class, I try to give you some options in print command and how can you actually utilize it the best way possible. All right. So start with operations. What can we do in Python? You know, as you can imagine, any programming language, it's a calculator in your hand is in its most simplest way. All right, if you want to describe it, you can do a lot of mathematical operations, addition, subtraction, multiplication, division. Raised to a power is a little different, so pay attention to that. If you're coming from MATLAB, right, in raising to a power, that's going to be something that can be a little confusing. We use whatever we use for multiplication, which is basically um, asterisk or a star. We use 2 for raising to the power. So a asterisk asterisk or star star b, 2 multiplication size b is a raised to the b power. What we use as raising to power in MATLAB here is a little different. This is a Boolean operation, which is described there. It's true if a or b is true, right? So it's similar to or, but when both of them are true, that doesn't return true. You might not even use this in your programming, and then or are the main logical operations that you're going to use a lot, right? And you see and or here, and it's just basically and, or is the vertical line on your keyboard should be above your enter keyboard. And you have comparisons, right? Is it equal to b or not? Is not equal to b? Smaller than or equal, smaller, greater than or equal, greater than operator, right? And we also have is and is not. So very similar to equal and not equal, with a little bit of change. In the case of when you're working with numbers, simple comparisons, they return the same value, but equal and not equal compare two numbers, whether or not they're exactly the same. Is and is not compare two variables, whether or not they refer to a specific part of the memory. So I'll give you an example, but let's just start with something simple, all right? A couple of, I'll take this and put it in a separate code. Feel free to move things around in these notebooks, right? These are notebooks that you're going to use as, I would say, you're going to use a lot as references. So whenever you want to do something, you want to code, you can just come back to these notebooks and look at how we use the specific command. All right, so running this, I assigned A to be 4, assigned B to be 3, multiplication, addition, and this is raised to power, right? I use this sign because that's something familiar, at least to people coming from MATLAB. But don't get confused. The way we raise something, a number to another number, is using 2 multiplication sign. All right. Now, print, as you can see, the first part is just something that I want to print. I put it in quotation. And the second part is the result of whatever operation. Now, you could go and just define it in a separate variable and then put it here. Would have given you the same result, right? Or you can just put it here directly. So that's just a taste whether or not you're going to use that variable or not, or sometimes even the taste in programming. Print also just maybe a little bit about print. Just here you can also, if you use single quotation, you're going to get the same thing. So it's just not double quotation. It can be single quotation. And as a matter of fact, you can even use triple quotations. I'll talk about it a little bit. That also gives the same thing. So all of these, Python understands that this is something you want to print. This is a string, which we'll talk about a little bit. Now, comparisons, right? Whether or not A is smaller than B. Now, the reason I keep putting print behind everything, if you just want to see the result of this, we can have a separate code cell and say A is smaller than B, right? And run that, right? That just returns false. Now, if you have multiple things in a cell, right? A is B, and run that, right? Only thing that is going to be printed would be the last line in that cell, all right? So since I have multiple lines here, I want to see the outcome of all of these. I basically put the print around it. So when it's run, it prints everything. But if you just have one thing in a cell, one operation in a cell, you want to see the output, just putting it there and running the code will do. So A is B, A is not B, right? This is like similar to equal or not equal. Both of them are used here, right? A is equal to B. In this case, my A was 4 and B was 3, so we expect these, right? A is smaller than B, no. A is B, obviously no. If you change this to 4 and 4 at the top, and you run this cell, you get different results, right? A is not smaller than B, but A is equal to B. So we get true, false, false, true, false, true. All right. What we want to talk about next is type of data, right? What type of data we're going to be seeing in Python. I intentionally kept this table of contents open on the left so you can get a sense of what we're looking at, right? We're going to talk about these 4 types of data, which are the main types of data you have to deal with in Python: numeric, strings, Boolean, and none. And dates and times, actually, that you can also count as a type of data. So C5. Let me close it so I have more space here. So the primary type of numeric are integers and float, right? An integer, again, if you're coming from some programming, you've seen these before. This is just to cover the bases, right? Integer can store some large number, but no decimal point. I'm going to think about it that way. And floating point numbers are represented by just float type, right? In a pretty straightforward way, I define the variable int, right? I call it just int val. You can call it whatever you want. Some random number there. Now type, the command type gives you the type of variable, right? So you can check the type of a variable. Let me comment this out so we can see the output. So the type of this variable is integer. If I raise this to a power, still going to be an integer. Now, one thing I forgot to mention, that one way to get help for a command, of course, is to use, as I said, question mark. But the faster way in Colab environment is just to hover your mouse over that command. In so many cases, you might get a relatively good, maybe short description of what that command does. Right? In this case, it's probably not the best description, but it just tells you the type, object or name, basis, and some other options that don't go into details. All you need to know is that want to check the type of variable, type would be something you go for. Then we have floating point, right? We can define either way, either use scientific notation, 1.345 times 10 to minus 8, or we can just define it the way we typically define with some limited decimal numbers. So I just use print to show you what comes out of it. It tells you it's a class float, and both of them are class float. If this one was this integer, it would have gotten integer and float. And the multiplication of two float number is also float. All right. So here is something to just play around with the code or with what we learn. Right. The question is, what is the data type of multiplication of an integer and a float type number? Right. The way you can test it is just by define a variable as an integer, another variable with a float, and do the multiplication, put it in a new variable, and check the type, and then tell me what is the type. All right, so what kind of, I can try it here. What kind of data type, or what is the type of the output? Did you guys try it? I'll define an integer. Let's define another number. This is float, any number. And then I put val multiplication, val 1 times val 2. And let's see what type we get. Type val. Oops. Right, so float. Right, once one of the numbers is float, the other one doesn't matter what it is. If it's an integer, you're still going to get a float. All right. Now, one thing I wanted to remember is that we do. Again, I keep referring to background as MATLAB because I notice a lot of you guys have MATLAB background. So if you are familiar with ceil or floor in MATLAB for rounding numbers, right? We don't really have it in Python directly. It's part of a math library that we are going to use later. We're going to use some of its functions later. But we do have this way of getting just the integer part of a number, right? So if you divide 3 by 2, I'm just going to put it in a new cell, 1.5. But if you use double division, right, sign, now what gives you is just the, it drops basically the fraction part or the decimal part of the number. So if in your calculation you need to just keep the integer part, or you want to get rid of the floating point number or the fraction part, you can use double division. Now, if you want to round, we do have round in Python. You can just say round 3 divided by 2. And that will gonna round it up to closest, highest number. Right? So these are something you can use in Python in your calculation. Any questions so far, guys? All right. So we talked about numeric. So you need to know about numbers, strings. All right. This is what I was trying to kind of mention when I was talking about print. Now you can define a string in different ways in Python. Could be double quotation, like double quote, single quote, and it could be triple quotes. And it can also be str val. I can add one here. It can also be double quotes. Right. So my string. There you go. All of these, from Python's perspective, they are the same. Right? Add it here so we can see the output. Run this. But all of these give me the same thing. Now, you notice that the one thing, there are cases that there is no way out of it, right? For instance, for the third variable, which is string variable, I have a quotation there, right? I have something written there that is interpreted as a quotation from Python's perspective, right? I have the apostrophe. So if I used single quote there, then things kind of get messed up, right? Because from Python's perspective, this is the beginning of the string and this is the end of the string. Then the rest is just whatever that is. Python doesn't understand it. So you have to use double quote sign. Now, other way of doing this is you can use backslash as escape to escape the character coming after that. So if I put a backslash here, that is going to escape, and that's going to tell Python that just let this, whatever is after this, let it go, right? Leave it as is. That is going to give me what I want again. But if I don't have it there, the best way to do that is just to use double quote, right? And sometimes if you have double quote in your string, you can use just triple quote. Or the same story, you can use escape character and you can still use single quote or double quote. Still do the job. I don't know if it's space there. You can go to the next line. This is kind of similar to MATLAB \n, right? It creates a new line. Oh, I put my name there. So much for creativity. And you can also refer to a specific character in a string. If I define this string as, or in this case, I just define the name of the course, right? But from Python's perspective, a string is just a bunch of separate letters together. So you can refer to any letter. Now, one thing I want you to pay attention, I put the note there, is that in Python, it's like Java. Some of you guys have background in Java. So it's like Java. Counting starts from 0. It's not like MATLAB. So when you say, when you go with 0, change it to 3. Well, when it was on 2, you just have to pay attention. Nothing was printed. And that happens because M is 0, E is 1, and then I have this empty space, right? Basically, something is printed here. It was just that empty space. So I'll just change it to 3. So I'll get the fourth character, which would be 1, 2, 3, 4, would be 3, right? Simple. Again, just to play around with this, if you were not playing around with the notebook already, remember these notebooks are yours, guys. So play around, write the code, move things, change things. The only way to learn how to code is just by doing it and practicing. So the question says, write a code that prints your first name, goes to the next line, and prints your last name in the next line. So I will do, here's my name, obviously. First name, all right, I put \n and put my last name. And I don't need these spaces actually, because that's going to add extra space. I run that, I get my first name, the first line, Masood, and I get my last name, the second line. I could do it in different ways. I could just say a string variable, Masood and Masumi, and then just print the string. Right? If you want to have it in a variable separate, you can just do it this way. This way is probably more professional when it comes to coding. Put things in a variable and then print it. Unless the printing is just something you want to do it once and don't want to deal with that string later. Hopefully it makes sense so far, guys. I interpret your silence as I'm totally understanding what you're saying. Everything is perfect and I'm perfectly following. So if that's not the case, ask questions, right? Now, this I put here because this is something that can be problematic or becomes problematic later during the semester when you're working with notebooks environment. Now, when you're in notebook environment, you create a lot of variables, right? And you can see that actually by going to the left on your Colab and click on variables. And this is all the variables I just created. right? So integer, it tells me what type is that. The shape, in terms of strings, it tells me how many characters I have in each string that I define. And nicer than that, even you can just click on it and it says where you actually, what is inside, right? Now, this is a new feature in Colab. We didn't have it before. And that was creating a lot of problems because you didn't know exactly what variables you have in your memory, and you could mess up, you could define some variable or override something. And whose was the way to go? Percent whose gives you actually what now we have it in a nice way in this variables option on the left. Before we didn't have that. Still, if you're using some specific IDE that doesn't have this kind of nice variable space, whose is going to help you in Python. Right? It gives you a good list of variables, the type, and what is in it. Now, there is also who that just gives you the variables. It doesn't really give you what is in it or what information it contains or what type of data is that. So who's and who or something and percent who give you the list of variables. And in this case, this is new and this is nice. We have it on the left, so you can always check. Now you can convert things into a string. You can convert any variable. In this case, this is just a float number. I am converting into a string by the command string. Right? If you hover your mouse over it, it gives you some description. It creates a new string object from the given object. Right? Pretty fast. This is just to show you what it was. Right? To print, maybe I can separate that to give it a little, let's say 10 times string. So it's going to be 10 strings to separate the lines where the first print happens and where the second print happens. Right? So it's printing A and it's checking its type, it's float, and then I convert it with string, put in a string, and you'll see now it's a string. All right, so we looked at numeric, we looked at string. When we have now, we have booleans. Very straightforward. You see these, they're like very common in every programming language, true, false. Right? There are only two possibilities for a boolean variable. Right. So typically they are the outcome of some comparison. In this case, let me actually make it even better and separate these. I define A1 as 1, B1 as 2, and I'm just printing them. For now, this is the best way of printing a combination of a string and a variable. Later on, I'll show you there are more modern way of printing in Python, especially fstring is the last most modern way of printing in Python that's very efficient. But for now, just take it as is, put the string and then whatever variable you want to print after. Right. So I made a comparison. Is A1 and B1 equal? The outcome is the false Boolean variable. Is A1 not equal to B1? The outcome would be true. Right? Of course, they are not because this 1 is 2. I don't need this line separator. Now I'm separating them in two different cells. And the same story here. Right? I'll just do the same thing to, I guess, make sure that I cover this part because there is a slide now. Let me mention this. So when we had Python 2, so this is Python 3. Now, historically, we had Python 2 up until 2.7, 2.8, and then we moved into basically at some point. I think now it's not supported, or it's almost not supported to Python 2, and everyone is using Python 3. There were a couple of slight differences. One of them was in Python 2, when you were dividing 3 by 2, for instance, you were not getting 1.5. You actually had to specifically mention that one of them is a float number, like 3.0 divided by 2 or divided by 2.0. That's one thing. So just wanted to mention that. Now, in Python 3, you also see there is a difference between integer and a float number, right? If I define 5 as 5.0, this hasn't changed. As 5.0 as a float, so this is a float number or floating number. This is an integer. You still get the same thing, right? You just it doesn't make, let's put it this way, it doesn't make any difference whether you define it as float or integer. Now, this was a little different in Python 2, but everything now is more uniform, I guess, in Python 3, and it does the same thing. Just piece of information that you might have needed, you might not even need it. But just, if you see some old code in Python 2, there might be some problems. Another thing in Python 2 that was different was printing. So in Python 3, we have print, put it in parentheses, and then we print it. Python 2, there was actually just a space, and there was no parentheses. That also changed, of course, in Python 3. If you do that, you're going to get an error. All right. So straightforward, numeric, string, boolean, none. None is basically a placeholder for a null value, right? When there is nothing, pretty much, you have none. Now, this becomes very important when we start working with data. Right? When you import the data, when you bring a data set to Python, there is going to be a lot of cases. There are going to be a lot of cases that you have missing values, and those missing values are replaced by none, right? Null value, not a value, nothing there. But just you can actually define a variable as none, right? And you can check whether or not A is a none. If I run this, I define A as a none. Of course, it's a none, and then I'm checking is A a none, and I get true as a Boolean result. Now I could say is not none, and that I get false because it is actually a none. All right. The last one is date time. The last type of, I would say, a variable you deal with in Python is date time. Now, this is something we are going to touch later when we work with data sets, maybe, depending on what data sets we're going to work with. But just it's there. Now, the way I had to introduce dates and times here, this type of variable, is that I had to look at this line of code. What this does, so Python, right? One thing I have to mention is that Python is a programming language, like general purpose programming language, right? Now, when we want to do different operations, we want to do different things, we have to use different libraries or modules in those libraries, right? You can refer them, they're slightly different, a module and a library, but you'll hear me a lot just use them interchangeably. So in this case, we have a datetime module. Datetime module contains some function. So a module, when you import that module, we call it in Python, if you've used R, very similar concept. So it's not like MATLAB, you have all the functions all the time available to you. You have to import a module or library that includes those functions that you need. We'll use this a lot and a lot. NumPy is a famous library, pandas, matplotlib, these are the libraries we're going to spend at least a class on each, right? So that's the idea. We have the Python as a general purpose programming language, but it doesn't come with all the functions we need. There are libraries and modules out there. In this case, I'm bringing module datetime, and this is a very specific way of importing it, right? I'm importing these three functions, datetime, date, and time, from this module datetime. So from and import is the syntax. So from some library or module, import, bring into my code, these functions. Now, you can directly import. We'll talk about it later, but just get a sense of what the whole structure is, right? So we have Python, and then we have modules and libraries. Now, in this case, I'm bringing date, time, date, and time, these three functions, because I want to just give you a sense of what date time is, this data type, right? So date time, this function, you can use that to define a date, right? Today, and the format goes year, month, day, hour, minute, second. Right? So, and the hour is military time. So it's after 12, it's like 1, it's basically 13, 14, 15, 2 becomes 14. This is the date for the last class. So I'll change it to 26. So 2022, January 26, time is 12, 43, at least on my computer. 43, and then second, just I put 0. 20 seconds. Now, a couple of things. Now, I am defining this date and put it into this variable dt. Now, what is dt? Let me, before I print this, I'm gonna cut and put in a new cell. So I define this variable dt, right? Now, dt now is a variable. It's an object, better to say. Again, object has a little bit of, there's a little different from variable, but you might see me using these interchangeably. So it's an object. Now, an object or variable, make it easier, comes with some methods, we call it, right? We call it methods. Where are those methods and what do they do? Actually, those methods are some built-in functions specifically for that type of object that we can use. Now, it's kind of mouthful. What I'm talking about is if I type dt and press period there, dot, I see a list of methods. See, it says built-in functions or methods. What do they do? Right? Depending on, they are not common, they are different for different objects. In this case, when we have a date time variable, right? I'll go back and show you what these are for a string. When we have a date time variable, for instance, we have all these built-in functions or methods available to us, right? The common ones that we can use for this. Now, let me print dt first. Here is dt. dt is a date time type of variable referring to this date. Now, from this, what if I just want to see the day of the months? It's 26. I just put period day. What if I want to see the months? This is the months in that day. I can see even the minute, and you see all the lists here. I can see the minute. Some of these I haven't even used. I can see the hour. I can see, I think, the second somewhere. There you go. I can see the second. Now, this list is long for every specific object, and I personally haven't used 90% of them. It depends on what your operation is and what you're trying to do. But the concept of method is something that is attached to a variable, and actually it's like a built-in function. So you can actually use it to get specific information or extract part of your, or make some changes to your object directly. Now, in this case, I use day, hour, and minute. So I said, this is the date we defined, right? In that date, right, this is the date. It says 26 January 2021, 12:43 and 20 seconds. Day is 26, hour is 12, and minute is 43. I can separately take separate things separate or separate them from the object and extract it. Now, this is if you use date now as a method or as a function within date time, it gives you the current time. Now, the only thing is that the current time is not the EST, right? It's not our time zone. It gives you just the universal time. Now, how do you want to get your time in time zone, I put the link in the Stack Overflow. We can take a look at that. It's not something important that you want to go into details. But just when you print, use time now, datetime.time now. And remember, this datetime should have already been imported from datetime module. If it hasn't been imported yet, you don't have access to it. Right? So that gives you datetime, gives you current date, right? But of course, the hour is not what the hour is, right? This is 5:47, 19 seconds. I put the link there. If you're interested how to convert it to your current time, feel free to use it. Just some practice, right? Print the current day, current month, and current minute for the coordinated universal time zone. That's I'll just do it, and you can, if you haven't done it already while I was talking, you can do it now. I encourage you not to do this and wait till we get there, because I'll give you enough time and I'll do it with you as a practice. So just follow along. Let's define some variable date. I'll just call it var date and say datetime dot now. Right, I'll just use dot now is good enough for us. And let's print variable date dot what are we asking? We're asking for the month, we're asking for a day, we are asking for month, and we are asking for minute. Just get the help from Python ID. You can make it a little nicer by adding comments. Day is not the nicest build. Doing it, but I'll do. The month is, and the same story for minute. The minute is. If I run this, I get an error because I have a typo there. I can eventually do that. M-O-N-E-H. There you go. And so I get the date, the months, and the minute. All right. I already told you about this. You will see the also name attribute instead of methods. Those built-in functions that are kind of giving you access to make changes or extract information from a specific type of data or variable. Now, one that is very common, the ones that are very common are the ones that are working with the strings. Right here, I'll show you a couple of examples. Right. So let's say I define this variable 1, and let's just be a little more specific and say variable string. And then I'll talk about this later. But let's define this variable string and see what methods do we have for that. Value string dot. Now, these are all the methods of built-in functions you have when you have a string type variable, right? That one was date time. Now, this is string type, a string type. When you have a string type variable or an object, you have all these methods available to you. What are these? Common ones. When you see is in front of a method, it means it can check for you the string. Right? In this case, we can say whether or not it's in uppercase, right? The first letter is uppercase. If I print val string here, right, the first letter is uppercase, the other 3 letters are lowercase. So if I test and say val string is upper, right, the result is false. There's no. So is testing that for you. Now, there's not just one. You can use is lower. Is it lowercase? It's false because it's not, because it checks all the letters. Now, these are just for checking. All these is, the ones that start with is, they're really checking. Some of them I used a lot, some of them I haven't used at all. So feel free to look at them. Some other things that are useful are changing that to lower and upper. Now, why do we need that? So if I say string.upper, the output would be test string, but all the letters are uppercase. Now, why would I need to do that? Can someone tell me any suggestion? And typically what happens is when it comes to comparison, I need to do that. If I have, let's say I have test is equal to test, it's false. Now, when you're working with data, there are so many cases that you're searching for a specific letter, right? You're searching for a specific word or a character. I would say word or a phrase. Now, if your word is just test, right, and you just say, let's search this specific data or a set of data to see if I have the word test in that. Now, if you have tests, it's not going to find those others. So what do you do is typically is that you convert all the words in your data that you're trying to search maybe into either uppercase or lowercase, so you don't miss anything, right? That's the most common place that this shows up, right? Because from Python's perspective, this is different from this, is different from this. So what I do, or usually people do, is that you convert all of them into lower or upper and then make the comparison to make sure you don't miss anything. This is one example. All right. Let's play around with these methods a little bit and try this question. So put your name in a string type variable and do these. Convert all the letters to uppercase, convert all the letters to lowercase, check if the letters are lowercase. They're easy, I already mentioned all of that. Count the number of occurrence of the second letter in your name. I didn't mention that, see if you can figure that out. Right? You want to count the number of occurrence of the second letter, whatever that letter is in your name. And the last one also, I didn't really mention that. Replace all the occurrences of the third letter of your name with N. Now, this is just a way of figuring out how can you replace a specific letter in a string. We'll start doing it on my end. My name, you already know my name since I keep typing it. All right, so part one, let's say one, let's convert it to uppercase. So do my name dot upper, and I'm just gonna print it. So when I run the whole cell, I can see that. The second part is to convert all the letters to lowercase. And my name lower. These are the easy ones. Third one, check if all the letters are lowercase. Print my name that is lower. Fourth one is something new. Count the number of occurrences. So I just put the printers to get the outcome. My name dot count. And then what am I counting? I'm counting the second letter. So for now, we can just put the second letter this way, but we'll talk about it. But as I said, Python looks at your string as a numbered set of characters, right? So if I go up here and the test value, like val string, as I said before, we talked about this. This first character is T, right? Counting, it starts from 0. The second character is E, and so on and so forth. So you can actually keep doing it and say the third character. So instead of putting your second letter directly, maybe a more professional way of doing it would be my name one, right? That would be the second letter in my name. And the fifth one, I want to replace that. So my name dot replace. Now, let's say you don't have any idea how does that work. Right? You hover your mouse over this, you see some description there, right? Tells you to replace the old. First input is the old, second input is the new. So there's a little bit more into this. We can look at documentation if you want, but we can actually say how many of them want to change. In this case, we said all of them. So I'm going to change the old would be third letter, my name, third letter. I'll replace that with letter N. I'll see if I get any error. All right, so upper, lower, is lower, it's false. Now, one thing I want you to pay attention is if I print the result, and so when we make changes, those changes are not permanent in our variable. If you want to keep that change in, as a permanent change, you have to put it in a new variable. So these are not in place changes, right? This is converting into a name with upper letters, but my name is still this variable. My name is still the same as the way I defined it, right? That doesn't change. So if you print it after this, after you converted everything into lower, right? This one, you still get what you put in the variable. So these changes are not changing the variable or object. Right? If you want to keep the change or keep it in a new format, you have to put it into a new variable. Right? You can just put it my name lower is equal to my name. Actually, my name dot lower. That is going to keep it in my name lower. And that would be a new variable you can actually use. And if I print that my name lower, then you have it in lowercase. Right? Just keep that in mind. These changes are not happening in your variable. They're not changing your variable. All right. Allow methods, depending on what kind of object you have access to. It can help you with your whatever operation you're doing. Next, I want to talk about control flow, and hopefully we get to talk about data structures and today too. So control flow, couple of control flow, I would say operations or situations we get into in a typical programming language, right? If a statement, for loop, while loop, right? These are the typical things that you have in a programming language. So just it's good to take a look at the format in Python and see how we can actually write those in Python. Again, we're not teaching programming, I would say, at the same time while we're talking about programming. This is just to get you a sense of, this is the same as Java, MATLAB, R. Well, set aside R. R is a weird exception in programming. C++, whatever programming language you know, is just pretty much translating that into the new syntax, right? So we're going to talk about these three main control flow structures, the if, for, and while. I put range there. I'll talk about what that is. It's not exactly a control flow, but I have to talk about it because something that we need in Python and we'll work with it, we'll use it. All right. So if statement, you guys have seen it probably. Pretty much is similar to any other if statement you've seen in different programming languages. A couple of things. So the structure if is part of the command, right? you have some expression, some kind of a Boolean value should be the output of that expression, whether it's a comparison or it's just a true or false. If you just want that if, probably in case of if, it doesn't make sense to have if true. But you usually have some kind of comparison there, right? Evaluates that comparison and the output is true or false. So if it's true, of course, you execute all the statements or lines of code within the if statement. If it's false, you just skip whatever is under if statement. Now, here's the thing about Python. The way Python interprets the control flow structures like if, while, and for is based on indentation, right? Indentations are super important in Python. Now in MATLAB, you can get away with that because you have an if and then there is an end somewhere. So you specifically mention where does this loop, this control flow structure end. But if you have, you're in Python, there is no such thing as end. And you see, I didn't put it in the structure for if. All we have is indentation. Right? So in this case, if you look at this example, right, it's a simple example. If A is equal to B, we make a comparison. If it's true, we print whatever we want to print. If it's not, or nothing is going to happen. It's just skip the statements below if. Now, if these three were equal, of course, if these two were equal, of course, you would have had the out. Now, look at the indentation, right? I have two spaces here. I go there and I do this, now it becomes 4. I'll tell you why, because the last time we had this class, actually it's a good thing to go back. Now, if you go to the gear option here in the setting and go to editor, I changed my indentation width in spaces to 4. Now, I could keep it at 2. The time I put these notebooks together, it was on 2, or keep it at 4. Now, there is this, I don't want to say argument, but there is a conversation in programming community that people typically prefer 4, because 4 is also something that you will see in a lot of other IDEs. Now, Google Colab gives you the option to use 2 or 4. Now, I put it on 2 because when I'm presenting this, I can use that extra space. But feel free to keep it at 4. If you keep it at 4, it's still going to run the codes that you have with 2 indentations. But when you write a code, right, as you saw, I press enter, the new line that basically interprets as part of the statement under if comes with 4 spaces. So it's a matter of taste again. If you want to keep it, you can keep it on 2. Right? If you keep it on 2, and then you just get 2. If you want, you can put it on 4. The suggestion is 4. Now, I'm suggesting something that I'm not doing. I know it sounds, not very encouraging, but as I said, I typically need this space in my notebook. But you see a lot of people use 4. Because 4 gives you basically 2 tabs. All right, I put it on 2, but if you have it on 2 or 4, doesn't matter. It just changes the way you write the code. Right, so we can, I don't go into details, very similar to other if statements in different programming languages. You can make comparisons, right? I used or, but we can probably use just or that we talked about. Maybe it's a little cleaner if you put everything. Python doesn't care as far as I know. But sometimes it's cleaner to either at least separate them just for the sake of your own to keep things clean. It's going to treat it differently. See what happened there, right? So I have A's 5, B's 5, and C's 4. So what am I doing here? I'm saying whether A is equal to B or A is equal to C, print this. Right now, A is equal to B. Right? In this case, A is equal to B. So this should be printed. But if so let me go back. That's not something I wanted to discuss, but now that it happened, if I just write it like this, well, it doesn't really do what you probably have in mind to do. you have to kind of clear things up and say, well, this is one thing I wanted to compare, and this is something else I wanted to compare. Be a little bit mindful of that. This is equivalent to what I did at the beginning, so still doesn't give you what you want. It's a little confusing. So if you want to talk about it later, we can talk about it, but let me not get into this in the lecture. For this case, my suggestion is keep things separated. So you have A is equal to B, that is true, so let's just print. And just for the ones who want to look into this further, right? If I do this, now you see things change. I'll leave that to you to look into it. It's a little bit of the way it behaves, but be mindful and aware of that. Now, you will see me a lot using or and this way, because then I don't have to be worried about that whole separating things. But if you are using this or this, just keep that in mind. That can be tricky. My suggestion, try to use or and. That'll do what we want to do in this course. All right. This you can change it to and. Right, it's not going to print anything because not everything is equal. Now, if I change it to 5, now. All right. So bottom line, this is your statement. Whatever is here, this is what the output should be Boolean. Right? In this case, you separate this. You can actually check that. If you run this, your output is just a Boolean. It's true. Now, if can be actually more complicated. This is the simplest version of if statement in Python. Right? Just checking a condition. Is that condition met? Yes, true, continue. If not, go past that, those statements. Now, the more complete version of if statement is if elif in Python. You've seen it as if else if. Actually, I don't remember why it's in MATLAB. Might be if else if. You guys know better, probably. So the complete version of that would be if the condition is met, execute these commands or go through these statements. If that's not, right, the orange set of statements, right, if the previous one is not met or is not true, check this one, elif. Now, if the first one is already met, you're done. If it's not, then it's going to check elif, right? And you can actually have as many elif as you want, as we saw in this example I put. And else is also kind of catching everything that doesn't really fit into any of those statements, right? You say if this is not true, the second condition is not true. It would have been better if these were condition 1 and condition 2, right? These two are not the same condition. I should modify that. And then you have whatever's left that you do not meet that condition. It's going to be executed after else. So the format, and I should have mentioned, pay attention to these columns here, right? Of course, you need one here and one after, so I should have mentioned it here. So hopefully you paid attention to that already, but just pay attention, whatever is in front of if nothing is there for no reason. Let's put it this way, right? If I don't have this here, I'm gonna get an error. So I kind of need a column there. All right, so a simple example. X is 0, it's going to execute this. If you execute this cell, it's going to check if X is 0. Well, if X is smaller than 0, it's going to print something, or in this case, it says it's negative. If that's not the case, check if it's equal to 0. If that's not the case, neither of those are the cases. Check if X is between 0 and 5. None of this is true. Just print the last thing. It's a very trivial if statement just to demonstrate how this works to just get a good image in your picture. So if I put, for instance, 2, then I'll get this output, right? But smaller than 5. Now this here, you can do it in Python. You can say x between 0 and 5. Maybe a more programming way of doing that would be x greater than 0 and x greater than 5. Right? You will see that in different programming languages. This is more common, putting an and having 2 conditions. Right? But in Python, you can actually combine these and just say x between 0 and 5. So that's something nice about it. One more thing, some things that just come to me and I realize that it's good for you guys to know is assigning variables. So you keep seeing me, I put variable A, for instance, is 10, variable B is 20, and variable C is 30, right? And then I can print these variables, A, variable B, variable C. Why do this is A? You see me, I do that. This is like very typical way in any programming languages, but in Python, you'll see a lot of codes that they assign them in one line, right? So we can say variable A, variable B, variable C as 10, 20, 30. We can actually do that. And it just goes with the same order as the numbers, and it assigned it to the variable corresponding to that number. It's something that if you want to assign multiple values in a code, instead of having them separate, it helps you to make it more condensed. One more thing, these are, maybe I'll talk about that later. So I can add this here in Python. You can assign variables in just one line using the following format. Now it might seem a little out of place in this notebook, but feel free to move it around, put it where you want to keep it. All right, here's an assignment. Let's do this question. We need to write a code that prints the third letter of our name if the value of a variable n is less than 3. These are like very simple, just to play around with these commands. Is less than 3 and bigger than 1, and replace none with appropriate. That is something I put as a note. Just gave you a general format of what I'm looking for. Right. Let's do this one. So I need to define my name. You define your name. Not the right place. Let me just at least use my own format. And variable name is less than 3. This is some input. So I'll use that to test my code. If n is less than 3 and bigger than 1, the other way around, print the third letter. So remember, counting, it starts from 0. So 0, 1, 2, that would be the third letter. Printing the third letter. Let's give n, first let's give 4, because out of that range, and check if it doesn't print anything. Less than 3, so meaning I can give n 2. Now it prints the second letter of my name, third letter of my name. Again, seems very trivial, I know, but it's just to practice with this structure. Right? Now I could put use n greater than 1, smaller than 3, right? As I said, you can actually do it in Python. If I keep this and say n greater than 1, smaller than 3, it'll still do. Right? So it depends on the way you want to code. We could use this. All right, so that's just for if statement. We use if statement very frequently, of course, for programming and checking conditions. But just remember that a lot of what I say today are required to understand what we're going to do later, not because we are going to use them directly, but because you also have to be able to read other people's codes. Right? You might know to do a lot of things in a certain way, but when it comes to coding, we learn a lot by looking at other people's codes. So one of the reasons I give you different formats and different ways of doing something, I talk about it like assigning variables or checking or doing some specific operations with strings, because you're going to see these in other people's codes. And then that's going to be, if you want to implement a code, which happens a lot in your work, or if you want to um, learn from someone's code. You might see these here and there, so it's better to be familiar with the structure and the way things work. You will see not too many situations that, especially in our work, we use maybe directly if a statement or talk about it for loop. But you have to be familiar with that, right? If you're not, then you get lost in someone else's code, or you can't even work with someone if you're collaborating. People have different ways of doing things, and can't really force someone to follow your style of coding. So just know a lot of these. All right. Any questions so far, guys? All right. Let's see how we're doing. To talk about for loop, and then we'll talk about the structures. This is something I wanted to mention. It's good to actually know. So one thing that you typically have in a typical like IDE or anything that you use to run your code is I already mentioned. So we have a lot of variables already, right? I use some define some random variables for different purposes here and there. I told you can look at these variables and on the left, or you can use who's to actually see the list of variables. I didn't tell you how to erase these, right? How do we delete a specific variable, right? Here, it's not like you can right click in a typical IDE to get that done. A typical way of doing it, well, it depends what your purpose is. If you want to just delete one variable or you want to clean up your variable space, right? If you want to delete one variable, it's kind of straightforward. You just put delete and just name of the variable, whatever variable you want to delete. Let's say in this case, let's check first. So I have my name as a variable. If I delete that and I try, oh, you already see that it's all gone from here. But now if I want to try to refer to that, well, it's not defined. Right? So del, which we'll use even for lists when I get there, helps you to delete. You can use that to delete a specific variable. Now, if you want to clean up your space, in this case, I want to do that because we already have so much variable sitting around. You can use %reset, right? If you do this, it is going to reset or clean up, or remove all the variables. They're going to have a clean variable space. If I click that, I have to give a confirmation because, as it said, once deleted, variables cannot be recovered. So we can just put yes in this case, because I don't really need those variables. And now I'm going to delete all the variables. Now I have a clean variable space with nothing defined. So just keep that in mind. You can add it to your notebook somewhere. If you want to erase all the variables defined in your notebook, you can use percent reset. If you need to delete a specific variable, use del and then variable name. And so just keep it somewhere as a note when you're working with notebook on Colab especially. All right. For loop. Kind of similar to a for loop you see in other programming languages. The general idea, right? You're just iterating over some statements until you get to the end of that loop. Now, we'll talk about data structure and I'll tell you what list and tuple is. But for now, you have a bunch of stuff. You can think of it as a vector, right? A list of stuff. And you want to iterate over that list, right? A collection of stuff. And for each iteration, you get some statements done. Of course, you can combine for with if statement, as you've done it probably in other programming languages. And there is also an else part in the for loop. It's not, I have never used it. And to be honest with you, until I was putting things together for a while ago, like a couple years ago, for teaching for loop, I didn't even know it exists in Python. So you will never see me using that else section or part. But what matters is the first part. For some variable, we do iteration. Now, how does that work? Let's look at examples of looking at this div, the format structure. I define the collection of variables, right? Define a collection of numbers in this case. Right? We call this list. We'll talk about it. Basically, just 1, 10, 3, 4, 6, just a vector. Now I say I want to loop. Now, pay attention. For is part of the syntax. In is part of the syntax. And again, you have your colon there and your indentation. Right? So whatever that has indentation, remember, that's how Python understands we are in the loop. Right? If I go here and go to the beginning, print out of the loop. Right? This line is not part of this loop, right? Because it's not, there is no indentation there. So what it does, this value is just some name, temporary name. It's not part of the format. It goes over the list, right? Just 1, 10, 3, 4 each iteration. Look at the list and say, well, first the value is equal to the first number or element of the list. Then in the second iteration, the value is equal to the second element in the list, and so on and so forth. You can do whatever you want with that value. Right? In this case, I defined a new value. I said value 2 is value plus value 1 squared, just to do some operation. I can just print both of them. So I run this, right? First, it's 1 squared plus what it is. Let me use a square. It's easier to interpret. So first is 1, right, in first iteration. And the squared of that is 1, of course. And then the second iteration is 10, square of it is 100, third iteration is 3, square of it is 9, and keep going to the end of the list. Right? Once it gets to the end of the list, it stops. So in this case might be a little different from what you usually see in MATLAB. Now, this collection of stuff can be anything, doesn't have to be number, right? I just defined 3 strings. Of lack of creativity, I just put str123 as names. And I said for, go take this variable I and make it equal to each member of this list in each iteration. Right? And just in this case, I'm not really doing anything fancy with it. I'm just printing it. Now, just you can do mathematical operations on strings. Now, what happens if I put 2 times I? Right? You will just get 2 strings. So if I put 5 times I, just just 5 strings. Right? To make it nicer, you can do. Actually, that doesn't make sense. But just you can multiply some string with some number, and it treats the whole string as one thing, and it says, well, we need it. It kind of creates a repetition for you. Sometimes you need that. That was just a side note. But that's the idea for a for loop. Right now, this is just a nested for loop. For loop within for loop, and then with an if statement. Just we can combine everything. Of course, you can come up with complicated set of loops together, and control flow structures. Right? I defined 2 lists: 1, 2, 3, 4, 5, 3, 4, 5, 6, 7, and I said for value 1 in list 1. So first iteration for the bigger loop or outer loop, value 1 becomes equal. It's equal to 1, and you get into the second loop. Once value 1 is 1, when it's 1, you iterate over the second loop, right? This part is going to be executed. Once this is executed and it gets to the end of the second list, right? So value 1 is 1, and then value 2 goes from 3, it goes to 3, 4, 5, 6, 7. Once we get to the end of the second list, we go back to the outer loop. Value 1 becomes 2, and then we print. Now, if I comment out this, you can actually see them better, right? So we say value 1 is 1. Once this is 1, value 2 keeps, we iterate over, go over the numbers in the list, 3, 4, 5, 6, 7. And then we go to value 1, 2, right? We're done with this inner loop, we go to outer loop. So this is the outer loop. This is the inner loop. Now I can also mix it with if, and I said, well, in every iteration in the inner loop, check the value 1 and value 2. If they're equal, then print the outcome. It's just a very trivial kind of solution of how you can actually mix things together. Now, of course, depending on what you want to do and what your work is, you may or may not need nested loops. Now, in Python, the logic is it's kind of follows the same logic as MATLAB. We almost always prefer vector operations to for loop programming. So for loops are they take time. They're time. I would say they're expensive in terms of execution time and memory. Right? So what we do is that we always try to find a way to avoid for loops. Of course, it's not possible all the time, but if we can, we do. All right, so let's finish the for loop story. There are a couple of things I want you to know about for loop. So one thing is that we have this very, very practical, useful, handy command called enumerate that you see that people use a lot when they use for loop. Now, what does that do? Let's say I want to iterate over this list with these 5 items, and I want to have the order of the item, where the item is, and the value. Right? So let me print it. What I'm trying to say is that I want to get the output of where this item 1 is. So since item 0 is located at element 0 on element 0, and it contains item 1. Right? This is pretty much the same as referring to the first element, right? Item 1. When I go to second one, is going to be item 2, right? So this happens a lot, that you want to know the order or where it is located and what is there. Now, if you don't use enumerate, right, one way to do it is this way. You can just define some counter and say, well, where it is, this first element, print the element, add 1 to my counter, and go to the next element. Now, that's really not a very efficient way. Other way of doing this is you can say for value in LST3, I was talking about enumerate, so let's use that. For value in enumerate LST3, that list, print for count and value, C and V. So let me separate these, print. Then I said you can multiply a string with some number, it's going to give you a repetition. I usually do this to create separation between out. See, what does the second one do? The second one does exactly what the first one did, but I didn't have to define a counter, add it up together, and I didn't have to do that. All I had to do was to use enumerate. So what does enumerate do? Enumerate has 2 outputs. First output is the count. I can use the full name. And the second output is the value. So in one command, what I'm getting is that I'm saying, go over this list, find the index for each element, which is count, or think of it as index, and print the value in that index. And this is something you will see a lot in Python programming. People use enumerate a lot because you want to iterate over a list and get the index or count and the value within for each index. All right, let's do this assignment or this practice. I want to write a for loop. This is very simple, right? Just create a list with your first name, last name, height, or whatever information you want to put there. And put a for loop or write a for loop that goes over the values in the list with your first name, last name, and your height, right? Prints the items with their associated counters. Now you can use either of these methods, right? Either the first method like this, or you can use enumerate. So I encourage you to use enumerate or just try them both. Let me put a comment. In Python, you see plus equal, minus equal, multiplication equal, and division equal in codes. Whoever is writing that code. Now, as I said, what it does is basically just a read version for, let's say, for I in, make some random set of values. LST1, I'm going to be using numbers. Let's say 1, 2, 3, 4, 5, 6, 7. List of numbers. Print. You can have I plus equal, for instance, just add some fixed number, 10. I run that. You see it prints. I have to print it. Print. As giving an error. I don't remember what error was. Oh, I'm doing too much. I have to put it in separate. Print variable that. There you go. Now all right, so it goes over that. You have your variable every time. It's 1. 10 is added to it, and then it's printed. So it's equivalent to ii is equal to ii plus 10. And you will see. This can be multiplication. Does multiplication. It can be division, can be subtraction. Right? So that's something you will see. These three, they show up in Python. Different codes. All right. Last control command is while loop. We don't really use it that much. I personally don't use it that much. There's always this problem once or if you guys have done programming, something that happens a lot is that you might end up doing an infinite while loop, and that's a usually big problem. For some reason, you don't see a while loop too much in a lot of codes, but you have to be able to implement it. Sometimes there is no way out of it, and sometimes it might make your life much easier. Right? That brings me to something. If something happens to your before I get into while loop, if something happens to your notebook when you're coding, right, things get stuck or you have an error, you can't stop it. I think I mentioned that in first class. You can actually restart your kernel, as we call it. So you can restart runtime. Now, if you do that, obviously you're going to use all the variables and everything you ran from the beginning of the notebook. But that's similar to opening and closing your code and resetting everything, if you want to think about it that way. So that's last resort kind of thing. All right. So while loop, of course, we have some condition. Again, we have while, part of the structure. We check some condition, whether or not we're meeting that condition. If the condition is met, statements are executed. If it's not, we also have the else clause there. That basically, if the condition is not met, else clause, whatever is under else clause can be executed. Now, else is optional, right? It's not something mandatory. You can use this structure without else and just have while condition. Executing those statements below the condition if the condition is met. So very simple, right? If I is equal to 0, if I is smaller than 6, print I, add 1 to I, right? That's what I was just talking about. So I is equal to I plus 1. Add something to I, and in every iteration, we're adding the number I and printing it. Now, if I didn't have this in my code, and it was just print I, this would have been an infinite loop. It never stops because I is 0. I is going to check the condition. Is I smaller than 6? Yes, print I. Keeps going inside this loop because I is 0 forever. Adding this, I'm saying in every iteration, add 1 to I, and then check the condition again, right? The condition is checked at the end of each iteration when you are writing the while loop. Just be a little careful with whatever you put as the condition. Make sure that thing is somehow changing within the loop. Otherwise, if it's true, it's going to stay true forever. All right, here's an example of breaking out of the loop. Right now, you can use while loop with a break statement. Now, break statement comes with an if statement. Typically, this comes as the general package. So, in this case, I said I have some x variable 256, and I'm checking whether or not it's greater than 0. Right? It is. I go over the loop. I check inside the loop in every iteration whether or not the total, which is 0 at the beginning, is greater than 500. Well, of course, it's not at the beginning, so nothing happens here. Then gets to the end of the loop or the last statement, it's going to add x to total. Again, to get comfortable with this notation, total is equal to total plus x. So whatever is in the X is going to be added to total. So if I run this, I get 256,512. Now, break, you can think of it this way, breaks out of the loop. All right, here is something for you to do. Write a while loop to sum up the numbers from 0 to 120 and then print, well, the loop is doing that. So prints the output every 20 steps. Now, the second part, I'll talk about it and how do we do that. So let's do this together. Now, I only gave you some piece of the code. I said we have some variable count, we have some variable total, right? And we want to say count starts from 0 and we want to go up to 120. Now, what to put here? Right? Let's figure it out. So I want to sum up the numbers from 0 to 120. So I'll say total, which is 0 at the moment, is equal to whatever is in total plus count, right? Because what is count? Every iteration is 0 at the beginning. I add whatever is in count to the total I have, and I'm gonna add 1 to count. So I go from 0 to 1, 2, 3, 4, 5, up until 120. I remember it said whatever condition you put for your while loop, make sure that's changing in your while loop. Otherwise, you're stuck in that while loop forever. So what this does, let me come out of the loop, count, and total. We'll see if I have any error there. I go to 120, so I don't need to. So I'm counting from 0 to 100, 120. The outcome is 121 because the last step, I should have done it this way. There you go. All right. Now this is counting and summing up the numbers, right? Now the second part is prints the output every 20 steps. How do we do that? Now there is this function in Python called mod, or in any programming languages we call it mod, which find the remainder of a division. And in Python, mod is basically done by percent sign. So what do I mean? What it does, it divides the first number by the second number and returns the remainder. So if I have 12 divided by 6, I expect that obviously the remainder should be 0 because 12 can be divided by 6. If I divide 12 by 5, I expect the remainder to be 2. So it divides the first number by the second number, it returns the remainder. Now I can use this, which you will see in programming again a lot for different purposes, to be honest with you. But I can use this to achieve the second part, to print the output every 20 steps. How do I do that? Can someone give me a guess? Or you might already know that. All right, I'll go ahead and just do it. Well, the way I do it is say, well, whatever is that count, right? This count is changing. If I look at it, let me print it. Let's print. Right, print in every iteration. No, it's going up, going from 1, 2, 3, 4, 5 up until 120. Right? It goes from 0 to 120. Actually, I think about it because the last counting, I have to keep that here. Yeah, right. Because the last number, I'm doing the summation here, just to know what my mistake was. I'm doing the summation here and then adding a number to the count. Right? So 119, when I'm at 119, this happens. One is, let me double check. When we are 119, I do the counting, add it to total, come here, it becomes 120. I go up, check 120. Oh, 120 is valid. So I add 120. This becomes 121. Then the condition is not true anymore. I'm greater than 120. So I come out of the loop. So we can, this is the right way of doing it. I was missing the last step. All right. So counting, right? The count changes from 1 to 120 or 121 in this case. I want to print every 20th step, print the output, print total. Right? So here's what I do. I say if count mod 20, right? If you divide the count, if count is 20, divided by 20 is 0. If count is divided by 20 and the remainder is 0, of course, we are talking about something that is can be divided by 20. So 20, 40, 60, these steps, I'll get the output. Right? If it's not, then of course it's not the step that I want to print. So I can print the total. The question can be interpreted a different way. I didn't say from 0 to 120 whether or not 120 is included or not. But now, if I do this, now I get the output every 20th step. All right. So if for loop, if statement, for loop, and while loop, right? For loop would be something we're going to use a lot. We talk about enumerate. I want you to remember that. And again, this here could be written as total plus equal to count. Good to get used to this. Count plus equal to 1. Right? This is equivalent. Or either works. If you want to have a more concise code. All right, range. What is range? Range is not part of controller structure. I just put it there because this is something I have to talk about, and we're going to see it in for loops a lot. And that's how we create for loops. Range, basically just a simple function that returns an iterator. Now, iterator is different from that list of stuff you saw, right? A good example, let's run this. So when I say range 10, and remember, help pops up, right? It tells you what is the structure. You can have just the stop, or you can have a start, stop, and step. Right? Range 10, by default, it starts from 0. I can just say 0 and 10, right? But look at the output. Output is not a range of stuff. It's not like in MATLAB, you create a vector from here to here, or some other programming languages where you can create a vector of numbers from, let's say, 0 to 10. It does say range, but it creates an iterator. Now, iterator is a list of numbers, a sequence of evenly spaced numbers, or integers we have to say, because it can't be float number. But it's not, think of it this way, it's not expanded. I can put from 2 to 10, this will still give me 2 to 10. Now, in order to expand this and get the list of the numbers, we use the command list. And we expand this. That gives you the what probably you wanted, right, from 2 to 9. And I'll talk about that. Pay attention. When we use range, Python starts from where we tell Python to start. It ends one number before the last number. Right? So it goes from 2 to 9, not to 10. If you want a 10, you have to put 2 to 11. Right? Just small things here and there. And you can define the steps. It can be every other number. Right? It can be 2, 4, 6, 8, 10. So range by itself, it returns a range type, not the list. You have to add list to it to get what you want. Now, this is just another example to if we can just define the step. Now, here's where it comes handy, or you see it. In for loops, when this, we talked about the structure of the for loop. In for loop, although this is not a list, but in for loop, we can actually treat that as a list. If you say for count in range from 0 to 20, although you haven't converted that into a list, right? Range 0 to 20 looks like this. What we were using in for loop was this. But I don't need even to expand this. For loop understands that this is a range and it can iterate over. So it's an iterator. It can go through it without expanding it, without we expanding it for this for loop. And so this you see a lot. It's a very concise way of iterating over some specific number or going over some commands for some specific number of time. In this case, 20 times. Oh, sorry, 19 times, because the last one is not included. All right, so you will see that a lot. Now, I'll go back to what I left behind. I said we'll come back to this one. This for loop, I was talking about how you can use enumerate and go over the items. Here is what you can do now. You can say count in range length LST3. So what am I doing here? I'm saying get the length. LEN gives me the length of this list. Length of this list is 5. 1, 2, 3, 4, 5 items are there. And create a range from 0 to the length of that. Right? That would be a range. Now that would be a set of numbers. Now I can use this to achieve what I wanted to achieve, right? I can say print count, because count is a number now, and LST3 count, right? Let me show you the different outcomes between these. Now I can do, this is another way of, right? Instead of going, if I want to have the index and the value of a list, one way is to do this, define a dummy variable and use it as a counter. Another way is to use enumerate. The third way is to use range. Define the length. So basically you are converting this list to a range of numbers, and you can iterate over the list by saying, well, this is item 1, item 2, 3, 4, one by one, and each what is inside the list for that item. To refer to that as this. Right? And pay attention, you've noticed that here is the difference. I'll talk about it when we get into lists, but there's a slight difference between the way we refer to the items. All right, I just wanted to complete that. Now, this is something that is important, right? Data structures. We are going to use, I want to go over these data structures. We are going to take advantage of 2 out of these data structures I'm going to introduce, right? I'm going to introduce 4 of them. I don't talk about set. Tuple is something I just want you to know about, but lists and dictionaries are the kind of structures that are very, very common, and we use it over and over. And they are going to help us to understand the structure of variables in other environments like pandas and NumPy that we talk about. Right? So what is a tuple? Tuple, putting aside the mouthful definition, immutable sequence of Python objects, it's the easiest way of defining stuff, putting things together, like defining a vector. Think of it that way. And we define that using parentheses. So whatever you put in parentheses is going to be a tuple. In this case, I just call it TUP and I said I want this tuple to contain 1, 2, 3, 4, these 4 numbers. I can print it and I can take a look at the data type. It's the type is tuple. It's a class of tuple, not data type. It's the structure, the type of the structure is tuple. You can access the values in tuple using brackets. So this gives you the access to a third number, which is 3. And as I said, counting starts from 0. So the first 0 is 1, the first element. The second is 2. Can actually put them all together. The third is 3. Right? So you can access the elements inside the tuple. We can create nested tuples, tuples inside tuples. Right? We have a tuple. It has one tuple that contains 4, 5, 6, and it has another tuple contains 7 and 8. Right? We call it nested tuple. If I print that, so 2 tuples nested within a tuple. Now, if you have a nested tuple, you want to refer to a specific element. Right? If I just use 1, it gives me the second element, which is a tuple, like 7 and 8. Inside that tuple, I can refer to the first element, which is 7. Right? That's how you refer to the elements in a tuple. The main thing about tuple you need to remember, because tuples are like a bunch of stuff listed together. The only thing about tuple is that you cannot modify a tuple once you define it. You cannot change, let's put it this way. You cannot change a number. You can't say, for instance, in this case, I have a tuple with these numbers and I want to change the third number, which is 3, and I want to put 5 there. I want to assign 5, replace that 3 with 5. If I run this, right, I get an error. It's like tuple objects does not support item assignment. You can't really assign. Once it's defined, it's defined. You can't really change it, change the item inside tuple. That's probably the most important thing about tuples. And also for that reason, it helps to save memory. So it's good to actually use them. We can unpack tuples, as we call it. Unpacking tuples is basically if I have a tuple including 4, 5, 6, I can just say, well, whatever is inside the tuple, put in these 3 variables. So A is going to be 4, B is going to be 5, and C is going to be 6. And so we can easily unpack a tuple. We can unpack a nested tuple, right? The same process, right? If I run this, I say, well, A and B, A would be 4, B would be 5, and C and D, there will be 6 and 7. I print that. If I didn't do it, if I did something like this, if I did A1, B1, and C1, and unpack that nested tuple, right? A1, B1, C1, I get the last item as the third tuple. When you have a nested tuple, you have to be very cautious about do you want to unpack the tuple within the tuple or actually elements within the tuple. So that's how you access and you can unpack the elements in the tuple. So it has some methods. Tuples come with some methods. If let me run this. Right, the count is one of them. Remember, I said each object comes with some methods, right? Count and index. I have never used index in my life, right? This returns the first index of the value. What comes very handy is the count. You want to count a specific number of a specific item in a tuple. Right? In this case, this counts the number of 2s we have in this tuple. We have 3. Right? You could count the number of 6s. It's still 3, I think. Maybe 4. You get 2. Right? So we can count the number of tuples. Now, in this case, it's a very short, small tuple, so you can even do it by looking at it. But it comes handy when you have long vectors with a lot of elements. And tuples do not have to be numbers. That could be strings. Right? String 1 and string 2, and then you can just print the tuple and see that. It could be So any data type, let's put it this way, can be inside a tuple. Now, I think if I remember correctly, you can do mix and match in tuple, right? You can have string, you can have integer, you can have float numbers, and you can have all of them in one tuple, or just you can even have them in tuple within tuple, right? 2.3 and 5.6 doesn't really matter. So it's pretty flexible. You can throw anything in there. Let's do this one. Just to practice a little bit with tuples. Define this tuple, unpack it, and count the number of 12s in this tuple. Very simple, just what we just did in Notebook. Now, list is very similar to tuple. The only difference is that, or what the big difference is that you can actually modify a list and you can change or assign a variable to a list. You can expand it. You can modify a specific value in the list. Tuple is fixed, so it's great when you want to save memory. You want to define something that you know it's not going to change. List is not, of course, as memory efficient. I mean, we're talking about a very, very slight difference, but it comes with flexibility and also the way you define it, right? List, we define them with brackets. Right? Now, remember, we define tuples with parentheses, but when we wanted to refer to a specific element in a tuple, we were using brackets. Lists, we define them using brackets. And you will see when we want to refer to a specific element, we still use brackets. So just keep that syntax in mind. List, you can define a list including similar to tuple, can be mix and match. Number, string, non-value I put there. You can convert a tuple to a list. Let's say you define the tuple and in the middle of the code, you realize that, oh, actually, you know what, you want to modify something in that. As simple as that. You just use list command and convert it into a list. So it goes from the way it was with parentheses to the way it is now. Now, one thing I may or may not have mentioned lower in the somewhere in the notebook. Let me finish this. So I want to refer to an item in the list. Right? In this case, I want the second item in the list, same way you refer to an item in a tuple. Right? Brackets starting from 0. You can assign the values in a list. And as I mentioned, the big difference between tuple and list is that list we can modify. So now I'm saying, well, if change the second element in the list from bar to bar 2. Right? If I print the list now, it's bar 2. So now I don't get an error. So it comes with that flexibility. It's awesome. Now, one thing about the list is that you can have list with tuple as an item. Just, mixing is totally allowed. So list with tuple, that's the name of the variable. I can have 1, 5, 1, 4, 10, and then I can have 2, 3, 5. I can have string. I can have 12.56 e minus 10. Print. List of number. List. No, that's not the variable I was with. Tuple. Right? So you can put everything in it. Now you can go back. You can even put list within a tuple. So a tuple can have an element, can have an item that is a list. And if I refer to, let's say, list with tuples, item, let's take the one that's tuple 3. Let me separate that. Let's see, that doesn't have it to separate the output. See, now the third item in this list is this tuple. Can refer to the first element within that tuple by just adding another bracket there. This both list and tuple are very flexible, except tuple you can't in terms of containing stuff. The difference is tuple cannot be changed and modified. List can. Now, if you define something as a tuple at the beginning, the middle of your code, you realize that you want it as a list, feel free to convert it using just list command. All right. I explained range here apparently, so I forgot that I have it down here in the notebook. I already talked about range, so I won't go over this. But now you understand probably a better place to refer to this now that we have the range. By itself is a range, but if I use the command list, it's going to convert it to a list. That is a data structure. Now, a couple of things we do a lot with list, which I did one of them top when I was going over trying to explain something. We can add stuff to the list. We can add one number at a time. We can add so many numbers at the same time and extend the list. We can drop or delete items from the list. As I said, it can be modified. It's not like tuple. We can what else? Well, let's go over these. So append, and these are methods. So if I define a list, let's say B list that I already defined. If I press dot, I get all those methods I said, right? Every object comes with its own built-in functions. So I can append, which is what we're going to talk about first. I can copy, I can count, similar to what we had for tuple. I can insert, we can talk about insert, pop and remove, reverse, and sort. These are the common ones. I haven't used copy. We just append, extend, pop, remove, reverse, and sort are the kind of stuff that you'll use for a list. Right? So looking at an example here, if I run this, I define an empty list. I defined an empty list here. If I print it, it's empty. Now I append the list by number 6. I said add 6 to the list. So now the list is extended. It's not empty anymore. It's 6. Now if I run this, if I append another one, number 8, at the same list and look at it, now it includes 6 and 8. I can just keep appending. You can just append another number. So that's how you can expand the list, which is pretty common when you're writing for loop, obviously, in programming. You want to expand in calculations, engineering. We calculate a lot of things, and you want to keep it in one place. Append is where to go. Right? You can get the length of the list, which I kind of mentioned that before. How long is this length? Is list has 2 elements, 2. I explained this, right? You can get the length. This is a different way of writing a for loop, right? If you want to go over, this is the equivalent to enumerate. Right? I just made it a little fancier. I said print string, the item number or the index of what is inside the list. This is the equivalent to for I in, over to say count and value in enumerate list 2 print. Let's follow the same format. List value count, following the same format. I use single code, so let me do that. And then list 2 and value. You store the same. I talked about that. It's like another way of doing it using a range function. You just get the length and get the range and iterate over it. Following is equivalent to the code of. All right, so I talked about range. Again, I don't get into that again. Now, the second method you see using for list is insert. Insert is also very practical. You can insert an element at a specific location. So append adds whatever you have to the end of your list. Insert, you can add an element to wherever you want in your list. Right? In this case, give you an example. I have a list of numbers, right? I print it. First, it looks exactly the way that I define it. I can insert, I insert it. So if I hover my mouse over it, or let's do even better. List one dot insert question mark. It says insert object before index. Right? So index is, I just wanted to get comfortable with this documentation. Insert, you say where you want this object to be and then what that object is. So in this case, I said I want to put this red before item number 1. Remember, 1 here is 0. Maybe I can put 10, 20, 30, 40, 50, 60, so it's less confusing. So remember, item number 10 is item 0, 20 is item 1. Now insert puts whatever you want to put in the list before the index you're referring to, which is 20 in this case, right? 0, 1. And it puts it it expands your list with that. All right, so get comfortable with using the documentation. You can remove the element by pop method. Dot pop, and you refer to which element you want to remove. In this case, I chose 2, which is basically the third element. Right, so we'll get 10 red, 30 because 20 is removed. Now pop, I'll go back to removing. There is a second method of removing that you can actually keep what is removed. We can add 2 lists together called concatenating, right? First list, second list, and you want to combine them as one list, just add them. Simple as that. Just use plus sign. You can concatenate. Lists. You can multiply, you can extend, right? So append adds the value, you can only add 1 item at a time. With extend, you can add as much as you want, right? If I define X as for none and some random string, and I use extend, right? Inside extend, I can put a list with any number of items. It's not like append that can only use for adding 1 value. So extend can extend the list as long as you want with what you give as an input. We have sort, right, which is basically, the name says it, sorting your list. In this case, if I sort 72513, it's going to be 1, 2, 3, 5, 7. That comes very handy working with vectors. We can sort in a reverse order. By default, if I hover my mouse here, hopefully it gives you us a documentation. So sort, see the pop-up, reverse is false by default, right? And I can say reverse and change, say as an option and say reverse is true, and I get a list that is sorted in reverse order. Now, one thing word you will see if I hover my mouse here, I just want to see the pop-up explain something. So it says stable sort in place. What does that mean? So if I look at A now, A is not what I defined it, right? I defined as 72513, but after I sorted that in reverse order, it's 75321. Remember when I talked about upper, lower, those methods? they were not in place method. When I was changing something, just to refresh your memory, I looked at the documentation so I can. So if I have var string as I am totally blank. You know what? Empty variable. I'll do. And if I say var string is upper, I print it, right? It gives you everything converted to upper, but it's not in place, because if I look at var string again, var string is the way I defined it. It's not in place. I have to put it in a new variable if I want to keep the outcome. However, sort is, get the calculation, is in place, meaning that it changes the variable. So be mindful, be careful with that. Don't get in trouble when using that in your code. You might get in trouble just not paying attention to that. It's an in-place operation. All right. Last thing. Well, let's do this, and then I think we still can cover this and get to the beginning of dictionary. Let's do this. All right. I just want you to use append, extend, insert, and pop, the methods we just talked about for this question, right? Just define that list, very simple list, doesn't really mean anything. Add those values one by one. So use a for loop and append method to combine them. Add the values 50, 80, 40 using one line code. So I have to use extend method. Delete the third item and the item of the list at that point. Third item, use pop method. Insert the day of your month, and when you put the day of your month, put it as a number, because sort can only sort lists with numbers.